Hi ladies and gentlemen, I'm sorry I can't be in class with you today, but we're going to do our notes digitally, so I hope that you find this video useful, and we're going to jump right in to having you check your homework and doing this do now on your own. So if you could go and check yesterday's homework, I have posted the answer key for you to take a peek at, and then also do this do now problem, and then when you are done doing those two things, come back here, unpause, and we will look at this together. So for this do now question, okay, we have to use the distributive property that was described yesterday to you when we learned how to multiply polynomials in one version. This is where we're taking a monomial and we're multiplying it by a polynomial. And we're going to distribute or multiply this 2x by each individual term in the polynomial that was in parentheses. Okay, we know to multiply because this monomial was written directly next to this parentheses. And when they're next to each other, we know that means multiplication. Please also keep in mind that in front of this x, because there's no number written there, no coefficient there, there is actually the value of 1. So this is going to be a 2x times a 1x, and that should have given us 2x squared. Then we see the plus sign. We're going to view that now as a positive 3 because of that plus sign. So 2x times 3y gives us a positive 6xy. Can't combine those because they're different bases, so we just write them next to each other, and that means multiplication still. And then 2x times negative 1, because we see subtracting 1, so we view that as negative 1. So a 2x times a negative 1, well, 2 times negative 1 is negative 2, and then we just have the x. So 2x squared plus 6xy minus 2x was the answer for your do now. All right. Let's start talking about a little bit of a different type of multiplication problem that we can come up with. Instead of a monomial being multiplied by any other polynomial, we can have different types of nomials. In this case, two binomials being multiplied together. There's going to be two methods I'd like to show you. This first method we call the FOIL method. It's kind of like PEMDAS in that it's not a real mathematical phrase. It's more of a acronym, a memory device for us to remember what to do. So you shouldn't ever in writing or an explanation say the word FOIL to describe this. I'll tell you what it really is in just a second. But we have this FOIL method for a binomial times another binomial. The FOIL acronym stands for first, outer, inner, last. So, but first, I mean the first two terms in each binomial get multiplied together. So we're going to view this as x times x. The O in FOIL stands for outer. That's when we take the outer terms. If we look at this as one giant phrase, the ones on the outside. So at the very start and the very end. And if we multiply those together, that's going to be an x times a positive 2. The I in FOIL stands for inner. So if we look at this as one giant phrase, we're talking about those two inner terms. So that's going to be a positive 3 times an x. And the last two terms refer to the last terms in the binomial. So that would be the 3 and the 2. So the last terms in each independent binomial. So positive 3 times positive 2. And so if we take each of these as mini problems for themselves, we can see that there's 4 individual multiplications that happen because the first item in the first polynomial is given to the 2 in the second, and the second item is given to the 2 in the second. So there's 4 multiplications that happen total. The first, x times x, is x squared. The second, x times 2, well, we usually write a coefficient first, so that's going to switch to 2x. 3 times x is 3x. And the last terms, 3 times 2, makes 6. So what we're going to do is take these 4 independent pieces and now put them together. So when they aren't like terms, by putting them together, I just mean writing them together with their operations. When they are like terms, I mean actually adding them with the rules we learned for adding or even subtracting polynomials together. So we can see that 2x and 3x are like terms. Those are going to get put together. But there's no other x squareds, and there's no other constants. There's no other values without a variable. So only the two middle ones in this FOIL method are going to be able to be combined together. So the x squared stays the same. However, a positive 2x and a positive 3x would add together to become a positive 5x. I'm stressing the positive, so I know to write addition. And this 6 was a positive 6. I'm stressing positive again because we need to write plus 6 for that. And so our final answer of when we multiply the binomial x plus 3 against the binomial x plus 2 is a trinomial x squared plus 5x plus 6. So this is one method. It's called the FOIL method. We're going to get the same answer even if we do another method. Okay, sometimes this is called the box method or the grid method. Okay, so I know it says grid method here, but some people refer to this as the box method because we're going to be using boxes. So as you can see, I wrote the first binomial at the top, the heading of the boxes for you. The left set of boxes, the left column, is supposed to be lined up with the x. The right is lined up with the plus 3, which we're going to view as positive 3. We're going to take the other one, and we are going to line it up on the left side of these boxes. So we're going to write it as an x to line up with the first row, and a plus 2 or a positive 2 to line it up with the second row. And what we're going to do is we're going to look at each heading and each row marker, and the box that they come together to, that is going to be where we go ahead and write their multiplication value. So an x times an x is x squared. We have a x times a positive 3, so that is going to end up becoming 3x. We have an x times a positive 2, so that becomes 2x. And we have a positive 2 times a positive 3, that becomes a positive 6. And so much like the previous example, we look for any boxes that are like terms. Those boxes can be put together. Everything else has to stay independent, and we just write them together with their operations. So there are no other x squareds. There were two items with an x, so I combined them together to become positive 5x. They lined up diagonally this time. That doesn't always happen, but it's pretty common that that ends up happening. And then we have the 6, which was a positive 6. And so we get the same answer if we try that method. Okay, so that is our basic rules for multiplying two binomials together. Okay, we're going to now try some practice problems. So on the next page of this document, you will go ahead and you'll see some practice problems. Okay, I'm just going to run through these real quick with you. Okay, if at any point you feel like you want to practice them on your own, just pause and then check my answer by restarting the video. All right, so if we look at example 1 here, I'm going to use the FOIL method for the first few. I'm going to do a y times a y times a positive 4, a negative 1 times a y, and a negative 1 times a positive 4. So y times y is y squared. Y times 4 is positive 4y. Negative 1 times y is negative 1y. And negative 1 times positive 4 is negative 4. We can see that these inner and outer terms were like terms again. They were both y's, so I can put those together. And that usually happens. It doesn't always happen, so just keep an eye out for like terms anywhere they might happen to appear in the problem. So when I combine them, I get y squared plus 3y minus 4 as my answer. If I try FOIL method for question 2, let's see what we would get. So I'm going to draw those 4 multiplications. Our first, our outer, our inner, and our last. 2x times x becomes 2x squared. 2x times negative 5 is negative 10x. 1 times x is 1x. And 1 times negative 5 is negative 5. Again, we have those middle terms as like terms. So putting them together, our final answer is 2x squared minus 9x from what we get from doing negative 10 plus 1, minus 5 on the end. So there's our answer as a trinomial. Again, usually the answers are trinomial when we multiply two binomials together. There's a special situation where that doesn't happen, which we will be taking a look at, but usually that ends up occurring. All right, let's look at example number 3. So here, first, outer, inner, last. 5 times 5 is 25, and n times n is n squared. So that's 25n squared for the first two terms. 5n times negative 5 would be negative 25n. 6 times 5n would be positive 30n. And 6 times negative 5 is negative 30. So if we combine those two n to the first powers together and rewrite our answer, we get 25n squared plus 5n minus 30 as a final answer trinomial. All right, number 4, multiply the firsts, outers, inners, and lasts. 4a squared times a is 4a to the third. 4a squared times 3 is positive 12a squared. Negative 6 times a is negative 6a. And negative 6 times positive 3 is negative 18. And here's an instance where we didn't get a trinomial, nor did we have combining like terms from the middle two values. And that was because this started with an a squared, and the other binomial started with only an a. So it caused non-like terms to appear. So we get our final answer just from those 4 multiplications straight away. All right, popping up, I'll show the box method for a moment. Even though I'm not as big of a fan of it, I'll just show it for those of you that might end up preferring this one. So when I have 2 binomials, I need 2 by 2. Okay, so the first binomial, x minus 6 gets written on top. Second binomial, x minus 3, all right on the side. So the x times x is x squared. The x times the negative 6 ends up being negative 6x. The negative 3 times the x is negative 3x. And negative 3 times negative 6 is 18. We do have 2 like terms. So if we put them together and write these out in standard form, x squared minus 9x plus 18 is our final answer. All right, I'll go ahead and I'll do box method again for this next problem. And it's still the same as that FOIL motion. For when I write the 4m plus 1 on the top and the 2m plus 6, I still get 4 things going on. 2m times 4m is 8m squared. 2m times 1 is 2m. 6 times 4m is 24m. And 6 times 1 is 6. So we get 2 like terms. 8m squared plus 26m plus 6 is a final answer trinomial. All right, these ones, I'm going to go back to FOIL. So our first 2 terms, 2a times 8a is 16a squared. 2a times negative 5 is negative 10a. Negative 1 times 8a is negative 8a. Negative 1 times negative 5 is positive 5. And those like terms come together to be 16a squared minus 18a plus 5. All right, our last one. You should notice, kind of like the one that we ended with in our first column, we don't have like the same types of things between these two. So we're not going to end up with those combining like terms in the middle as we have been for the previous 3 in this column. All right, so if I do first, outer, inner, last, x squared times y squared, just as x squared, y squared. They're not the same base, so we can't combine them. X squared times x, I can do that. That's x to the third. Remember, if there's nothing written in front, it's just a 1, and 1 times 1 is still 1. So if you put a 1 there, I'd be fine with that. Negative y times y squared is negative y to the third. That's from the negative 1 times the positive 1, gives us negative 1. Y times y squared is y to the third, using our exponent laws. And then lastly, a negative times a positive is a negative, and y times x, well, they just have to be written next to each other. Okay, and because of how the structure was, it was written in standard form already for us when we did these. A 4 degree, 3 degree, 3 degree, 2 degree. So it went in descending order. So there's our final answer for that one. All right, I'm gonna stop this part of the video now. This was our first method. I don't want each independent video taking too long, so I'm going to now jump to the second part of the notes. So go to the next page and go to the next video.